Hello students, welcome to the IMS Gate Academy. So how are you all? So hoping that the everything will be fine and okay. So yeah, like you know that we had started the series which was the PYQ. Okay, so in that we had completed the one PYQ that is of GATE 2023, and we had seen the couple of good question from the electrical machine which was asked in GATE 23 exam. Okay, so let our journey to be in the next path. Okay, so in this session I will going to take the GATE 2022 question for only the electrical machine. Okay, so let us start with the very first question, and before that student, please do share the session link with your friend. It is very important because we want here to be a healthy competition between all of us, so that we will going to learn a lot of things from one another, isn't it? So please do share the session with your friend, and also do not forget to hit the like button. It is very important to mark your attendance by hitting the like button. All right, so shall we begin? So let us start with the very first question which was asked in GATE 2022, and this question is from the induction machine. Okay, look at the question. The frequency of the stator and the rotor current flowing in a three-phase 8-pole induction motor are 40 Hz and 1 Hz respectively. The motor speed in RPM is. So the question is very simple. Just we need to use the formula. Okay, like if you're knowing the formula, you can easily reach to the solution part. Now look at here. First, let us write the data which are given in the question. So, the induction motor is 8-pole. Stator frequency, let me take F1, which is 40 Hz, and your rotor frequency, which is F2. This is given as 1 Hz. I need to determine the motor speed, which is NR. Okay, this is the rotor speed or motor speed, which is equal to NS 1 minus S, where NS is the synchronous speed 120 F by P. So let me write here NS, which is 120. F means supply frequency. Since I had taken F1, so let me write F1 divided by number of poles. So always remember, this NS is the synchronous speed, 120 F is the supply frequency. Now this S is what? Sleep. Now let us first calculate the synchronous speed, NS. So this is equal to 120 into the supply frequency is 40 divided by number of pole is 8. So this is equal to 15 into 40, which is equal to 600 RPM. Now, the only unknown is sleep. How to calculate the sleep? Before that, we must be knowing one relation, that rotor frequency F2 is equal to S times of supply frequency. How many of you are knowing this relation? Please let me know how many of you are knowing this relation. If you are not knowing this relation, then this question cannot be solved. Okay. Now since F2 is given as 1 Hz, sleep is unknown, and F1 is 40. So can I say your sleep is equal to 1 by 40. Now substitute this S and your NS value in this equation. So your NR is equal to 600 times 1 minus S is 1 by 40. So this is equal to 600 into, take the LCM, we'll get 39 by 40. So this is equal to 15 into 39, which is equal to 585 RPM. See the solution part. It is very simple. Even this question can be solved in the mind itself. Okay. Yes, excellent, Prakhar. Excellent. So yeah, 600 into 39 by 40. Like if you know this relation, F2 equal to S into F1, and this relation NR, you can easily solve this particular question in your mind without picking the pen and scribble pad in the GATE exam. Alright, so the correct answer is 585 RPM. So here we need to feed the value as 585. So I hope this question is clear to you. If you are having any doubt, please do post in the chat box. I will going to answer all the queries. But term and condition is what? It has to be the technical doubt. Okay, chalo. Let us move on to the next question. A 280 volt separately excited DC motor with an armature resistance of 1 ohm and constant field excitation, it is very important line, drives a load. The load torque is proportional to the speed. The motor draws a current of 30 ampere when running at a speed of 1000 rpm. Neglect the friction losses in the motor. The speed in the RPM at which the motor will run if an additional resistance of value 10 ohm is connected in series with the armature. So, on yesterday's session, I told you whenever you are going to have the question from DC machine, this question is basically from the DC machine. Whenever you are having the question from the DC machine and if they are asking the question related to the speed, then we need to going we will going to have the two cases. Okay, Prakhar. Sir, please tell me gate 23 transformer question where leakage reactance was asked. Okay, maybe I need to look out into that question. Maybe there was some error in the gate question itself. So because of that reason, I had not entertained those questions. Okay, because there was some ambiguity in the question. All right, Prakhar. Chalo. So let us move ahead. So whenever you are going to have the question with respect to this DC machine, always you are going to have the two cases, case 1 and case 2, and the two equation, first one torque wala and the second one EMF wala. So with the help of these two equation and two cases, you can solve any question from the DC machine. All right. So see, this is separately excited DC motor. So let me write all the data given. Vt equal to 280 volt and this is separately excited DC motor. Next, armature resistance is 1 ohm and constant field excitation means IF equal to constant. Okay, Prakhar. So please, Prakhar, do share the session with a friend. Okay, so that they may also join and we will going to have the wonderful session over here. All right, so let us move ahead. The constant field excitation means IF is constant. So whenever field current is constant, it implies that flux or field flux is also going to be constant. Why, sir? Because your flux is proportional to field current. This is very important, as flux is proportional to the field current. All right. Now the load is what? Proportional to your speed. This is the rotor speed. Now the motor draws a current of 30 ampere. It means that your armature current is 30 ampere. So let me take this current as 1. IA1 means for the case 1. Next, when running at a speed of 1000 RPM. Next, neglect the losses, RPM, this is, neglect the losses in the motor, the speed in the RPM at which motor will run if the additional resistance. So let me take additional resistance as RE, which is equal to 10 ohm. And since this has been added, so this is this speed we need to calculate. N2 speed that we need to calculate. Done? Now look into the problem. I am 100% sure that, please listen very carefully, I am 100% sure that whatever final answer will come, it will always be like it is going to be less than 1000 RPM, because I know that from the speed control of DC motor, if resistance is going to be added in the series with the armature, the speed is going to be dropped down. Okay, so how to judge whether your answer is going to be correct or not? See the final value, it has to be less than 1000 RPM, because this resistance control will give you the speed less than the given speed. Okay. So before that, let me draw the equivalent circuit of separately excited motor. So just a second, let me draw it. Okay, all right. So this is your field winding. Okay, VF, and we know that in the stator the field winding is DC. So this is DC supply. Let me take the current here is IF and this field winding resistance as RF. So this is your field winding. Let me draw the armature. This is external resistance RE, armature resistance RA, and this is your rotor, means armature. And this is your armature circuit. Terminal voltage is VT, and since this is a motor, so current will come here like this from terminal to inside the armature like this. So this is your field circuit, this is your armature circuit, and here you are going to have the EMF as EB. Okay. Now let me take case 1. In the case 1, apply the KVL here. Apply the KVL. What we are going to get? EB1, which is equal to, in this circuit, which is equal to VT minus IA1 RA. Why I have not taken RE? Because in the case 1 means when the speed was 1000 RPM, there were no external resistance. So RE is taken as 0 for the case 1. And yeah, so this VT is what? VT is 280 minus IA1 is 30. Armature resistance is 1 ohm. So this is equal to 250 volt. I hope this is clear to you. Done? Next, case 2. EB2 is equal to VT minus IA2. Now this time we have added the resistance. Okay, please give the answer in the chat box. Whatever answer you are getting, please answer in the chat box. Alright. So this is equal into RA plus RE. Done. Now this EB2 is unknown, that we need to calculate. VT is 280 minus IA2 is unknown, and RA plus RE 1 plus 10, this is 11. Done. So here we are having the IA2 as unknown. So we will going to use the torque equation. So suppose if you want to find the current, then use the torque equation. If you want to find the speed, then we will be using the back EMF equation. After a couple of time, you will come to know why I am saying this kind of point. Okay. Now, as given, as we know, back EMF is proportional to phi into N, that is the rotor speed. Okay. Now since the flux is constant, so can I say back EMF is proportional to your rotor speed, which is here, na? Kahan gaya? Yeah, N. Alright. So my dear friend, from here I can write EB2 by EB1 equal to N2 by N1. Okay. So let me inbox this. So let me take this equation as 1, this equation as 2, and this equation as 3. Done? Now, here when you substitute the values EB2 and EB1, what we are going to get? EB2 is 280 minus 11 IA2. Yes or no? 11 IA2 divided by 250, which is equal to N2 by N1 is 1000. This is given in the question. Now IA2 is unknown. If I have the IA2, I'll be having my answer. Now since I have used one equation, now let us come to the next equation. Let me inbox this just a second. So whatever formula, whichever I am inboxing, those formula are very, very important, and most of the time we will be using those formula only. Okay. All right. Now next let us come to the torque equation. So T, as we know, torque developed in any machine is equal to or proportional to phi into Ia. Okay. So this is the torque which is developing inside the machine. Please do not get confused with the load torque and the developed torque. Developed torque is the torque which is the electromagnetic torque developing inside the machine, and load torque is the torque of the load. Okay, both are different. Now since flux is constant, this is proportional to Ia. Now under steady state, always your developed torque is equal to load torque. Now see, this is proportional to Ia and load torque is proportional to your N. So can I say IA is proportional to N? Now from here IA2 divided by IA1 is equal to N2 by N1. So from here I will going to get one relation, IA2, which is equal to IA1 is 30, N1 is 1000. So we will be getting 0.03 N2. Okay. Now substitute this IA2 in this equation. Sorry, where it is? Yeah, in this equation. So let me take here. Sorry. Let me remove this. This should not be the equation. Okay. Yeah, this will be your equation. This is equation 3. Substitute IA2 in equation 3 and see what value we are going to get. So 280 minus 11 into 0.03 N2 whole divided by 250, which is equal to N2 by N1. So N2 divided by N1 is 1000. Alright. So let us see what we are going to get. 280 minus this is 0.33 N2 and here 250 by 1000. What we are going to get? So it will be 0.25 N2. See, here we are having only one unknown. So this implies N2 is equal to what? 280 divided by. This 2 will going to be added. Now bring to the denominator side. We'll get 0.58. So on solving this, we will going to get the value. Just a second, let me calculate. So 280 divided by 0.58. So I am getting the answer, not the answer, like this value, 482.758 RPM. So this is not going to be your answer. Like some may going to say that, sir, since we have got the answer, so I will going to get the full marks. No, my dear friend, this is not your answer. Because if you see carefully, in the question, they are asking the answer to the nearest integer. So if you are going to feed this value, your answer is going to be wrong. So what is the nearest integer to this? Your nearest integer is 483. Now this is your answer. Got the point? This is your answer. So please be careful about the question statement, whether they are asking up to 2 decimal or to nearest integer or even in some cases nearest to next integer. So for that you should be very careful. Alright, so this is your answer. So let us come to the next question. A star connected 3-phase 400 volt. Any doubt in the last question, Prakhar and everyone? A star connected 3-phase 400 volt 50 kVA 50 Hz. Synchronous motor has a synchronous reactance of 1 ohm per phase. Just a second. 1 ohm per phase with negligible armature resistance. The shaft load on the motor is 10 kilowatt while the power factor is 0.8 leading. The loss in the motor is 2 kilowatt. The magnitude of the EMF per phase excitation EMF of the motor in volt is. So we need to calculate the excitation EMF. So let us first write the data which are given in the question. So this is star connected 3-phase and terminal voltage. So not a terminal voltage, basically this 400 volt is what? Terminal voltage. So indirectly it is given. So VT, let me take L, means line. Okay, L for line. VT is terminal voltage. So this is 400 volt. 50 kVA. This is complex power or apparent power? This 50 kVA is the complex power or apparent power? 50 kVA, 50 Hz with negligible armature resistance 0 ohm and with synchronous reactance XS. This is J1. Next, the motor has a load, that is shaft load, P shaft. This is equal to 10 kilowatt. And cos phi, that is power factor, cos phi is 0.8 and this is lead. Okay, so from here I will going to get phi value as cos inverse 0.8 is what? 36.87 degree. And the loss in the machine PL, let me take this as PL, which is 2 kilowatt. So magnitude of EMF, and this is in per phase. Na? Always be careful about the line and the phase. Okay, so this is per phase we need to calculate. Now, for such kind of question, we require the equivalent circuit of the synchronous motor, because the question is related to the synchronous motor as well as the power flow diagram. So, let me draw the equivalent circuit of the motor. So, just a second. Okay, so look at here. Okay, so this is armature resistance, which is 0. In the question it is given. This is XS, and this is your terminal, which is VT. All right, and here you are going to have the armature. Okay. All right. So yeah, this is your EF phasor, which is EF at an angle minus del, where del is what? Load angle, and for motor del is always negative. And since this is a motor, so current will come from the terminal. So this is your armature current. Got the point? So since this is a motor, so input will be electrical and output will be mechanical. Is it clear, everyone? So input will be mechanical, the input will be electrical and output will be your mechanical. All right. So yeah, from here we need to have the equation of the EMF. So how we can write the EMF equation? So let me write here. EMF equation means EF at an angle, EF at an angle, EF at an angle minus del is equal to VT. So in the synchronous machine, we will going to take the reference to be a voltage, this terminal voltage. Okay, since it is given a 0.8 is leading, so with respect to which parameter it is leading, so always we will going to choose the terminal voltage as a reference. So this will be VT at an angle 0 degree minus IA phasor and ZS phasor. IA phasor means magnitude and angle, like that. So VT, since this is your line voltage and it is a star connection, so what will be the phase voltage? 400 by root 3. So this will be 400 by root 3 at an angle 0 degree minus IA is unknown. This is magnitude at an angle phi. Got the point? This phi is the power factor with and it is leading the terminal voltage at an angle of 36.87. Okay, and this ZS is the synchronous impedance. So here RA is 0, XS is what? J1. Okay, so this is J1. Got the point? So here only unknown parameter is magnitude of IA. How we will going to calculate? Here we will going to use the power value. Okay, so for that we need to understand the power flow. So let me write here. Okay, so power flow diagram in synchronous motor. So as we know that input is what? Electrical, and output will be your mechanical or soft power. Okay, so see how it will going to look like. Okay, so yeah, first we will apply input power. I hope this is visible, this color is visible. So input power will be your electrical power. Done. Okay. After that, we are going to have the what to say, your stator. Okay. After that, we will going to have the stator. So P stator loss. So this is the total loss of at the stator side. So when you subtract the stator loss from the electrical power, what we are going to get? We are going to get the air gap power. So this is air gap power. So the power which is getting converted from electrical to mechanical is known as air gap power. So see, there is a gap between the stator and rotor such that the rotor is going to be rotate freely. So the power which is transferring through the air gap or through the gap, basically, which is the air. So because of that, it is said that air gap power. Okay. Now after this, we will come to the rotor side, and when you subtract the rotor loss, so P R L, and after that mechanical loss. So this mechanical loss is what? Friction and windage loss, and we will going to get the shaft power, or this is also denoted as output power, or this is also denoted as net power. Got the point? Now if you see carefully, here input is what? Electrical. So in three phase, how we can write the electrical power? PE, this is equal to root 3 VL IL cos phi. Done. And what is the output power? This output power is what? P shaft, which is equal to torque of the at this shaft into omega r. Omega r is what? The speed of the rotor in radian per second. Speed of the rotor in radian per second. Now since this is your input power which is electrical, VL is what? Do not think that it is a load or like that. It is your line voltage and line current. But in the synchronous machine, this VL is what? VT. But we need to take line. Okay, we need to take line into IL. IL is what? Line current. So which is here? Armature current. IA. And cos phi, like this. Clear? Any doubt till this point? Now see carefully, this electrical power indirectly is given in the question. How? This power, this is given as 10 kilowatt. Shaft power. This is given as 10 kilowatt. And all the losses, mechanical loss, rotor loss, and your stator loss, these all are given as 2 kilowatt. Somewhere it is 2 kilowatt. Okay, see, 2 kilowatt. So the total loss here, sorry, just a second. Till this point. So this total loss is 2 kilowatt. Hai ki nahi? So when you add this 10 kilowatt and 2 kilowatt, we will going to get the real power which is transferred from the electrical side. Okay. So what is the total power? 10 plus 2, which is 12. So this is 12 into 10 to the power 3, which is equal to root 3 into VT line is 400, IA is unknown, and cos phi is what? 0.8. So from here, I will going to get the IA value as, just a second, let me calculate. So 12 into 10 to the power 3 whole divided by 400 into 0.8 into root 3. So this is 21.65 ampere. We have got the armature current value. Now substitute this value here in this equation. So let me change the color. Okay, all right. So this 400 by root 3 is what? This 400 by root 3, this is 230.9 94 at an angle 0 degree minus IA we have got as 21.65. Now listen me very carefully. This is J1 is what? We can write in polar as 1 at an angle 0, isn't it? J1 is 1 at an angle 0 in, 1 at an angle 90, 1 at an angle 90 in the polar. And phi is what? 36.87. So whenever the angles are in multiplication, they are going to be added. Whenever the angles are seems to be in the your multiplication, the angles are going to be added. Just this is the basics of your complex variable. All right. So what is the total angle? 90 plus 36.87. So this is 126.87 degree. Done. So yeah, if you look at this particular thing, the first parenthesis, it is what? In polar. So it is like this, r at an angle theta. So this I can write as r cos theta plus j r sin theta, which is what? R e to the power j theta, a Euler form, So using this concept, what we are going to get? 230.94 cos 0 plus j 230.94 sin 0. Sin 0 is what? 0. So this is equal to 230.94. Next, minus, yeah, see, 21.65 cos 126.87. So here we are going to get 21.65 cos 126.87 degree plus j. Here r is 21.65 sin 126.87 degree. Okay, so 230.94 minus, cos 126.87, it is what? Minus sin 36.87. So it will be 21.65 into minus 0.6. This value is minus 0.6 plus j 21.65 into this value is 0.8. Now you must be thinking that, sir, this we can directly feed we can feed this value directly in the calculator, na? But my dear friend, you are forgetting one thing. This question was asked in GATE 2022 and you are not going to have the physical calculator. You are going to provide it with the virtual calculator, and in that there is no provision for the complex number. So here how we will going to get the magnitude? First we need to separate this value in terms of real and imaginary, and from there we will going to have the magnitude. Got the point? So please do not use the physical calculator over here. Okay, all right. So yeah, this value is what? For this we can use 230.94 and see this minus and this minus will become plus 21.65 into 0.6. So this is 243.93. Next, minus this minus and this plus will become minus j. So 21.65 into 0.8. So this value is 17.32. So this is your EMF. But I need to find the magnitude. So magnitude will be what? EF. Magnitude will be root over real ka square 243.93 real ka square plus imaginary part ka square. What is imaginary? Minus 17.32. Minus 17.32 whole square. So when you going to use this, when you going to simplify this equation, so let me simplify this. 243.93 whole square plus 17.32 whole square. So we will get the value as 244.544 volt. So this is your per phase induced EMF. So in the question they have asked the per phase excitation EMF in volt, okay, but rounded to nearest integer. Okay, very important line. Suppose if you are going to fit this value, your answer is going to be wrong. Now let us round off this. So what is the round off value? Like this value is closest to 244 or 245? It is closest to 245. Sorry, not equal to answer basically. Answer is 245 volt, as we need to provide the answer to the nearest integer. Got the point? Any doubt? Let us move on to the next problem. A 3-phase 415 volt 4-pole 50 Hz induction motor draws 5 times the rated current at rated voltage at starting. It is required to bring down the starting current from the supply to 2 times of the rated current using a 3-phase auto transformer. If the magnetizing impedance of the induction motor and no load current of the auto transformer is neglected, then the transformation ratio of the auto transformer is. So transformation ratio is what? This is X. Now, so this question is basically related to the starting of the induction of 3-phase induction motor. So what do you mean by starting? Means starting how the induction motor is going to be start. 3-idiot wala. No, it is not that. Okay, so starting of the induction motor, what it means? At the time of starting, at the time of starting of the 3-phase induction motor, the current is very high. A current will be very high. So maybe it will be around 1000 ampere, even 2000 and so on and so forth. So if such amount of high current is going to be flow into the windings of the 3-phase induction motor, your winding is going to be damaged. Okay, stator winding and the armature winding. So therefore, we need to adopt certain techniques such that we must limit the starting current. So that particular thing is known as starting method of 3-phase induction motor. Got the point? Okay. So yeah, since this question is related to the auto transformer, so I can directly write, if we know the relation, that the starting current when we are going to use the auto transformer, the starting current IST will be equal to X square times of ISC. What is X? Auto transformation ratio. What is ISC? This ISC is the short circuit current. Means a current which is flowing under the rated voltage at the time of starting. The current which is flowing in the induction motor at the time of starting but at rated voltage is known as ISC. Got the point? Okay. Now see, in the question it is given that the induction motor draws 5 times the rated current, which is full load current, at the rated voltage. So it means that your ISC is given 5 times of IFL. 5 times of IFL. Next, now it is required to bring down the starting current from the supply to 2 times of the rated current. So IST is to be bring down as 2 times of IFL. But when we are going to have the auto transformer? When auto transformer is employed. Done. So substitute this value over here. So this is equal to 2 times of IFL X square. ISC is 5 times of IFL. Yeah. So when you solve this, we'll get X square as 2 by 5 or X equal to root over 2 by 5. So this is equal to, let me solve it, root over 2 divided by 5. So this is equal to 0.63. So round off to 2 decimal places. So 632. 632. So when you round off this value to 2 decimal places, we'll get the answer as 0.63. The question is very simple, but for that we must be knowing this relation. This relation is very important. Okay, just a second. So this relation is very important. So please remember, what is ISC? ISC is the current which is entering into the induction motor when rated voltage is applied at the time of starting. Okay. So let us come to the next problem, which is our two generating units are rated for 250 megawatt and 400 megawatt, have governor speed regulation of 6% and 6.4% respectively from no load to full load. Both the generating units are operating in parallel to share a load of 500 megawatt. Assuming free governor action, the load shared in megawatt by 250 megawatt generating unit. So basically this question is related to the parallel operation of the synchronous generator. Alright. Now this question is basically, as I told you, is related to the parallel operation, but at the same time it is related to the droop characteristics. Okay, those who are not aware with the droop characteristic, they may going to find, like, once this lecture is going to be get completed, so please go to the foundation course. Okay, in the foundation course of the electrical machine, I have taken the topic droop characteristic. Okay, so you can be master of this particular topic once you going to attend those video or those particular lecture. Got the point? So go to our YouTube channel, and in that you will going to find the playlist of mine, foundation course of electrical machine by Nikhil Gaurav sir. Got the point? So yeah. So the rated value PR1. So let me take this 250 megawatt as a generator 1. Okay. So this is the rated value 250 megawatt, whose droop characteristics or the speed regulation is 6%. Okay. And this is for generator 1. Let me take for generator 1. Similarly for generator 2, PR2, R is what rated value na, or full load value, which is 400 megawatt, and it has the droop characteristic as 6.4%. So let me take generator 2. Now both generating units are operating in parallel to share a load. So PL, this is a load, and this is given as 50 megawatt. Now since you are having the two generator, so definitely this two generator is going to supply the load na. So this PL is nothing but the power supplied by generator 1 as P1, power supplied by generator 2 P2, which is 500 megawatt. So let me take this as equation 1. Done. But I need to calculate the load shared in megawatt by the 250 megawatt generating unit. It means that the P1 I need to calculate, because this P1 is supplied by the generator 1 or 250 megawatt generator. Got the point? Any doubt? Okay. Now for this, always draw the droop curve. Okay. Now one important line, your speed is decreasing from no load to full load. From no load to full load. Now see here. Since this is a question related to the synchronous machine, and your rotor of the synchronous machine is always rotate as at a synchronous speed, isn't it? Now this NS is what? 120 F by P, where F is the supply frequency. Can I say your synchronous speed is proportional to F, or F is proportional to NS? This relation is for generator, this relation is for motor, and this relation is for generator. Like this looks to be same, but both are different. How? Here speed is depends on the frequency. So frequency is the initial value. So frequency is what? Electrical, na? And output is mechanical. So input will come first, after that output will come. So this relation tells us that how frequency is getting converted into speed, which is nothing but the case for the motor. And this equation tells you that how speed is going to be converted into frequency. So mechanical to electrical, which is nothing but the generator. Now, since your frequency and speed are interrelated with respect to each other, it means that if the speed is decreasing, or whatever the speed regulation we are going to have, the same speed regulation we will be having for the frequency. Done? Got the point? Now, if you draw the droop characteristic, which may be looking like this. Now in this, try to learn the concept. Okay. So here, your speed is reducing from no load to full load. So whenever there is no load in the frequency, then the means basically if there is no load on the generator, then the supply frequency will be the no load frequency. As soon as we are going to put a load on the generator, the speed at the same time frequency is going to be reduced like that. क्या ये बात समझ में आया? देखो ये रिलेशन की बात कर रहा हूं. जस्ट अ सेकंड, लेट मी चेंज द कलर. ओके, सी जे डी ओमेगा बाई डी टी. This is mechanical power minus electrical power. Since this is a generator, so this will be your output, this will be your mechanical. Now, when you give the load on the generator, what it means? Your electrical power is going to be increased. Na? So, when electrical power is going to be increased, it means that your change in the speed will going to be reduced. Means speed is going to be decreased. So, if the speed is going to be decreased, then frequency is also going to be decreased. So, once the frequency is going to reach to the specified limit or to the safe limit, which is practically, suppose if the no load frequency is 50 Hz, then the safe limit is 47.5 like that. If the frequency goes beyond the 47.5, there will be a situation of the blackout. What it means? That grid failure. What it means? Power grid failure. Means whole electricity of the state is going to be off. Means there will be no electricity in your state. This was occurred in 2014 or 2012, somewhere like that, in Delhi or in Northeast Assam, like that. I'm not able to getting the Northeast state name, but yeah, from Delhi to, like, it has to be transferred to the some Northeast side. So since because of the load, it is not getting transferred, the whole state electricity is what? Shut down. So that is nothing but the grid failure, and it is happening because your frequency is going to be reduced to a drastic level. Okay. Yeah. Come to this question. So let us consider the no load frequency. Sir, आपका कोर्स कैसे मिलेगा? अंकित आनंद. अंकित, आप जो है हमारे YouTube चैनल पे जाओ, IMS Gate Academy. In that you will going to have one tab for the playlist. In that playlist you will going to see the number of courses like foundation course, most expected concept. So वहाँ पे मेरा नाम आपको दिखेगा निखिल गौरव. So in that you can find. Acha, for the paid course you were saying, see, you can find the details given in the description box. So in that you will going to come to know that how you will going to opt for the courses. ठीक है अंकित? In the description box all the details are given. Or got the point? And also please you can join the Telegram group. Link is already given. So in that someone will going to help you out, but it is better to go to the description box and look out for the details. All right. Or else the alternative is you can visit to our IMS website. Okay, IMS website. In that you can going to have all the information that you are looking for. ठीक है अंकित? All right. So see, here you are going to have the two generators. So let me take this right hand side for the generator 1. Okay, and this left hand side generator 2. Do not think that here generator 1 will going to have the positive value and this side generator 1 will going to have the negative value, plus x-axis minus x-axis. No, it is not like that. So this thing is for the generator and this part is for the generator 2, generator 1 and generator 2. Now since no information is given about the no load frequency, so whenever no information is given, we will going to assume the no load frequency to be same for all the generators. Got the point? It is very important point. Please note it down somewhere in your note copy. So whenever no data is given for the no load frequency, always we will consider the no load frequency to be same for all the generators. So let us take the no load frequency as F and L, and this is your frequency axis and this is your power axis. This is your power axis. Okay. Now, if you see carefully, here the slant or the slope is somewhat lower than this particular slant. It means that the slope here is what? Lower, and here the slope is higher. So for the generator 1, what is the drop in the speed? Drop is from no load to full load to 6%. It is by 6%. So if it is F and L, then at full load, let me take FL1. For the generator 1, full load 1. So what is drop in frequency from here to here? It is 6%. It is 6%. So this frequency is what? 0.94 F and L. Got the point? Since from no load to full load, the drop in frequency is by 6%. So what is the actual frequency at full load? 94% of no load, isn't it? Similarly, for generator 2, it is 6.4%, isn't it? So this particular frequency F full load 2, this is equal to 0.936 F no load. Got the point? Any doubt till this point? Please do let me know, everyone. If you are having any doubt, please shoot in the chat box. I will going to answer all the query. Done. All right. So yeah, this is the full load frequency. What it means? The frequency at which rated power is given. So for the generator 1, what was the rated power? The rated power was 250 megawatt. So let me take megawatt here. This is megawatt. So 250 megawatt. And for the generator 2, it was 400 megawatt. Now if the generators are operating in parallel, if the generator are operating in parallel, it means that all must be having this same frequency. All must be having at same frequency such that it is going to supply the load. Got the point? Let me repeat once again. Whenever generators are operating in parallel and they are supplying a load, it means that generator is going to operate at same frequency. So here if you see, this is your same frequency. For the generator 2, the frequency is, let me take, kya le le? Let me take here frequency. Let me write frequency. Okay, so let me take this particular frequency as F. This particular frequency as F. Got the point? So in this frequency, the load is supplied. So if you see what we have taken, P1 and P2. So this is P1 and this is your P2. Got the point? So at this frequency, the generator 1 supplying this power and generator 2 supplying this power. So what power we need to calculate? P1. P1 we need to calculate. So how we will going to do? How we will going to do? We will going to use the trigonometry. Sir, आप synchronous machine में कैसे trigonometry ला रहे हो? अरे बहुत easy है. See, this angle. Let me change the color. See this angle. Let me take this as theta. So since this triangle and this two triangle are equal, why? Because this angle is also theta. है कि नहीं? अरे yes or no? So tan theta perpendicular by base. In the same way, perpendicular by base. Got the point? So F and L minus F. So let me write FNL minus F whole divided by, what is the power here? In this triangle, ये छोटा वाला triangle, power is P1 divided by FNL minus, FNL minus F full load 1 whole divided by P rated power is what? 250. Done. So, but F full load is given as 0.94 FNL. So, let me write FNL minus 0.94 FNL whole divided by 250. So, this is FNL minus F divided by P1. So, from here I will going to get P1 as equal to, जल्दी से बताओ क्या आ रहा है? FNL minus F whole divided by, this value will be what? 0.06 FNL into 250. So, let me simplify it. P1 is equal to P1 is equal to FNL minus F whole divided by FNL into, let me take this 0.062 here. So, 250.06. So, equation 1 somewhere we had taken, na? Yeah, this is equation 1. So, let me take this as equation 2. Okay. Now, we have got the relation for P1. Similarly, for P2 or generator 2, look at this angle, alpha. So, this angle and this angle will be same. I mean to say that, just a second. I mean to say that this triangle, done, and this bada wala triangle, these two are similar because your these two angles are same. So FNL minus F whole divided by P2, this is equal to FNL minus F full load 2 whole divided by 400. Got the point? See, FNL minus F divided by P2 is equal to FNL minus F full load 2 divided by 400. Okay, all right. So, what relation we are going to get? FNL minus F divided by P2, this is equal to FNL minus F full load 2 is given as 0.936 F no load, okay, divided by 400. So, from here I will going to get P2 expression as F no load minus F whole divided by F no load into 400 divided by, so it is 0.064. This value is what? 0.064. So, let me take this equation 3. Done. So, let me add a page. Now, from equation 1 and from equation 1, 2 and 3, what we are going to get? See. So, total power is P1 plus P2 equal to 500. Substitute this value, this one and this one. What we are going to get? So, F no load minus F divided by F no load. See, this term and this term are common, isn't it, when you are going to add? So, let me take this as a common. So, we will get 250 divided by 0.06 plus 400 divided by 0.064, which is equal to 500. This is given in the question. which is 500. So from here, F no load minus F whole divided by F no load. So this is equal to, let me calculate what value I am getting here. So 500 divided by 250 upon 0.06 plus 400 upon 0.064. So I am getting this value as 0.048. Any doubt till this point? Anyone is having any doubt? Please do let me know. So what after this? What after this? I need to calculate P1, na? P1 is what? This expression. Therefore, P1, which is equal to 0.048 into 250 divided by 0.06, because this value is what? 0.048. 250 divided by 0.06. So when you solve this, we will going to get here 200 megawatt. 200 megawatt. So the power that is supplied by the generator 1 or by the 250 megawatt generator that we supposed to be calculate over here is 200. So correct answer for this question is 200. Alright, any doubt in this question? Always draw the droop curve for such kind of problem. Suppose if you are not going to draw the curve now, maybe you will going to have the difficulty in solving the gate problem. Okay, so please be clear about the question, and wherever it is possible, try to draw the diagram. If you come to know that you are facing any difficulty, just draw the diagram. 50% problem is going to be solved over there. All right. So with this, we have completed the GATE 2022 electrical machine question. So I hope you have enjoyed all the things. If you are having any doubts, please do post in the chat box. All right. And guys, one request, if you have liked the session or if you have enjoyed the session, please hit the like button, and also do share the session link with your friend, because it keeps me motivating all the times. And also please do not forget to subscribe, because we are coming up with a new initiative in the month of December as well as in the month of January. Okay, and for that you need to press the bell icon as well, so that you should be notified first. I want you to be the first to get notified for our all upcoming sessions. Got the point? All right. And yeah, if you want to join the Telegram group of IMS GATE Academy, the link is given in the description box. So go to the description box. In that you will going to find the link, and the PDF of this particular session is going to be shared on that Telegram channel. All right. So yeah, if whenever you are going to have a doubt, like once the video is going to be uploaded, even if you are going to have any doubt, please please post your query in the chat box or the comment box basically. Once I will get the time, I will going to rectify or I will going to resolve all the doubts ASAP. All right, as quickly as possible. All right, so please watch the lecture once again. Definitely it will going to be rectify all of your doubt, even if you are having anything. All right, so yeah, let me end this session, and we'll meet on next week with a new GATE paper, which is GATE 2021. All right, so bye bye, and take a very good care of your health.